you, and thank you, Wolfgang, once again for your lecture. I think it was really condensed and there's a lot of things to talk about, so I hope you also have questions. But first of all, I would like to point out two things. First, I also like that method, and I think it's really appropriate music form to think technology and artificial intelligence because of this non-human perspective that is in that matter. So I like that you like that method. And the second thing is the liberation of artificial intelligence from a human, from this comparison of human intelligence and artificial intelligence. I think this is one of the crucial things right now, because there is a lot of buzz going on, a lot of discourse also about AI safety, AI alignment, including regulation and so on. Some, let's say, wars between different actors in tech industry and so on. So the core idea of AI, so-called AI alignment, is to align artificial intelligence, the development of artificial intelligence, with human values, human cognition. And I think this is a very tricky situation because, first of all, we must really define what human values are. And second, we can limit the potentiality of artificial intelligence or concrete artificial intelligence AI systems. So my first question is your comment about that, about this buzz discourse right now about AI safety, AI alignment, regulation, and so on.
Yeah. That's adopting of AI system to human or cultural values is maybe the desire to still integrate even AI into the system of how our symbolical cultural mechanism works. Like in 19th century, in the Industrial Revolution, machine theory somehow has integrated the steam engine, for example, up to philosophy and other cultural mechanisms. Now, that's what I call the anthropocentric or cultural-centric way of treating AI. I think this happens, since I'm a trained historian as well, I look what happened to technologies when they were new. Of course, there is always, for the first generation, either being afraid of new technologies or trying to integrate it, to make it, to remediate them with the familiar tools. Like when cinema was invented in 1895, for example, we can see how the first films were all looked like theater, because it was trying to integrate it. There is a cultural lack to realign it with the values which are already there. And then only the next generations, with Griffith and other authors, they discover Eisenstein, they discover the montage, and then the medium develops an aesthetics of its own, something which cannot be remediated, but it becomes productive when you liberate it and let technology itself play with technology, experiment with technology. And we are with AI, although AI has been already there, but for lack of computing power, it was only a question for a few specialists. Now it becomes an everyday discussion and experience, but we are still in this first generation experience of AI. And I'm waiting for this next step when we liberate AI, when we experiment. That's why I use the word experiment so often. But philosophers in France like Gaston Bachelard or McCullough, who in the US is responsible or has been responsible for the comparison of electronic computing and the brain, the electronic brain metaphor. They always always mention things like epistemic toys. So we have to use them as knowledge toys and not be hindered immediately by this concentrating on the ethical or even social agenda. I mean, you come from sociology officially, at least.
Yes, yes.
But even in social sciences, with Bruno Latour and other great, or Niklas Luhmann in Germany, there is a group of sociologists who say, okay, let's not limit the idea of sociology and society to an assemblage of humans, but include non-human beings. That's what Latour was famous for, to say society is humans, but non-human beings as well. If you come home and you still have a key and you open the door, unlock the door, the key knowledge is part of the human society, although it's of society, although it's a non-human toy, but it's part of it. And now with AI, we can even extend the idea of the social to communication within and between machines. And that's why the generative adversarial nets were an artificial art critic battles against an artificial data. And then they rival with each other, and they improve, and then we see there is a non-anthropocentric way of letting technology go. You want to, yes?
Yes. You're still coming from very humanistic perspective to include the other into our world, and dialogue is very technocentric, in a way that we are talking about a kill switch, if it becomes sentient, which we don't know if it will. It's like on the level of a child of 3 or 4 years. But you didn't talk about theory of labor and capital and how it impacts the everyday life of people who are displaced, whose work is displaced because of emerging technologies like AI.
Mm-hmm. Yeah, but well, I don't say that this is not an important issue, but this is a lot of discussion is about that. That's why I saw my job now as a media theorist to say, well, there is for a moment I want to decouple the debate about AI from the question of how it is part of late capitalistic circulation and power structures. And this was but this discussion is being done. To this I did not want to contribute. But I wanted to say there is a way of looking techno-philosophically at the fascination of AI. Because this is something of European tradition as well, I would say, or Occidental tradition. That there were people like in early Greece, Anaximander and Heraclite and others, who speculated about things which are not practically relevant in everyday economic and power structure and political life. And still they are worth to be investigated. That's, I defend the possibility to think about AI and bracket it for a moment from the social and economic agenda. But I read with my students a piece of Karl Marx, which has been neglected for a long time, although everybody could read it, which is called the so-called machine fragment. Because there's an interesting moment when Karl Marx, who cared about the impact of machines and factory work and automatization, he cared about it. And then he used the word, the general intellect. Very interesting to see Karl Marx writing about the general intellect, because he said, what if the factories become completely automated? Then the workers become in a way redundant, and then they have time, and this time can be used. And he went so far to say that even science is responsible, already working on the side of the capital in producing the knowledge which allows this complete automatization. So there is, even media archaeology takes care of this moment where the challenge, the political economic challenge can be addressed. But what I defend as an academic is that I have the freedom to be free for a moment from the immediate political reflection, because it's knowledge which I'm interested in. And I don't, for a moment, I don't even care whether this is misused. AI is being misused, or it's Google or the data owners which have the power of the big data. We know that, and this battle is going on, and it is important to discuss that. But within an artistic or academic frame, we should be allowed to become more speculative about it.
So you divorce technology from politics altogether?
Yeah, because technology is the curiosity. That's why I use the word technologos actually instead of technology, because technology is already the knowledge of applied technique and things like that. But technologos is the human curiosity about things going on in the world which are not human. The fascination with machines, like in the Baroque, suddenly a robot can behave like a human, although we know it's not a human. What's going on there? And this curiosity, which created philosophical thinking, like René Descartes, we discussed it in yesterday's lecture. And then we start to compare, we have questions like, do machines have a soul or consciousness or not? Those questions are not relevant to answer the problem of how they are being used or misused in a political or power structure. That would be the Foucault version of doing discourse analysis. But there is the beauty of knowledge worth in itself. And that's what I call the academic freedom. That's why I try to be not naive in saying it's remote from political questions, but it cannot be, it should not immediately discussed in a political context. And I know my students, they want to discuss it now in the ecological context, in the power structures, and there is a new political bias now, which is right. But at the same time, philosophy, there should still be allowed philosophy of technology which follows questions of which you are not knowing what they are relevant for.
If I may add, the full automation, this Marxist sense, actually in one way means the end of capitalism. Because capitalism is based upon the exploitation of human labor. So it's a very ambivalent situation, and I think now the mainstream dominant discourse is, in my opinion, if I may, more technophobic than technocentric, because there's really a lot of questions about safety and existential risk and so on. And the second thing is, I think we should talk here about intelligence. So my question is very simple: how do you define intelligence? And should we think of intelligence in this large scale, evolutionary scale? Because the idea that intelligence is only human, or this really human-centric, anthropocentric idea of intelligence actually is only a few hundred years old, because classical metaphysics is based upon God, so like some super intelligence agent or something. So I think you are dwelling in this, on this field of intelligence in this big, large scale of evolution. Am I right or not? How would you define intelligence?
Yeah, I mentioned already Alan Turing, who invented the digital computer and the algorithmic-driven computer, the way we know it in 30, he wrote this paper in 1937, but he's well known, of course, for a second paper, which he published in 1950, Can Machines Think? And he's the same mathematician Turing. First sentence is, we should ask, what do you mean by thinking? And then he invents the so-called Turing test. He says, well, if a machine can make you insecure that you don't know are you communicating with a human or not with a human. It's like the first chatbots. When you receive an email, how do you know that this email has been written by a human? And Turing already in 1950 said if a machine, a typewriter or something, telex machine, because the computer didn't exist in this form, can give us the impression of a reasonable argument, then this machine thinks. And this was taken by Jacques Lacan, whom I mentioned as well, and whom the Ljubljana-Lacan school developed further. The so-called intelligent machines are not just a challenge to humans, but they remind the humans that there is a machine-like part in the human psyche itself. So it's reversing the argument. Most of discourse is how human can machines become. This was already software industry for computing, the dialogue with the computer, to make the computer more and more behave like a human. That seems to be the ultimate goal of computing, software industry, and even of artificial intelligence. That you can have conversation with the machine as if it was a human. Or this chatbot idea is about that. Now this is the one side, but the more this happens, the more this machine reminds us that we ask ourselves, to what degree are we machinic ourselves? And that's why I in the beginning mentioned language. The way we communicate in an articulated, coded way, which is language, this is machinic. And that is what defines the human against other animals, like we discussed yesterday. If this is tool making, language, these are technologies. Bernard Stiegler, the French philosopher of technology, he insisted again and again that the human and technology are co-originally. It doesn't make sense to talk about the human and not think about technology. It's coexistent. And so I want to get away from this. There is human and intelligence on one hand, and there is artificial intelligence on the other. And that's why the radicality of philosophical thought and mathematical thought, like Turing and Lacan and others, and earliest Greek philosophy already, has been the liberty to ask to what degree is what we call human technological already. Because the cultural is unnatural. It's ne-antropic. We are talking here, McLuhan, the media theorist, reminded us of that. There is artificial light. Otherwise, it would be completely improbable that we sit in a dark room and have conversation. Now, this is unnatural, to be in a dark cave and still have a philosophical discussion like we have. Now, this is culture. Culture is inventing technologies which resist so-called natural behavior, and this extends to the question of intelligence as well. So what defines the human is technological already.
So what would be the intelligence, what would be the definition, or which attribute will go to intelligence? It's like not human, unhuman, human, just intelligence. It's like itself, in the space, here, universe. What is intelligence?
That intelligence would be the capacity of applying tricks I would even say. Why do I work? Because not only acquiring knowledge, but being able to make use of knowledge in applying tricks. To be inventive in a way which is not just a mechanical reproduction of knowledge. Now, why do I use the word trick? Because the ancient Greek word for trick has been mekane, from which we have derived the word machine. So, the idea of intelligence itself is already in its core mechanic.
But how do you...
It's not... Maybe we can then try to say there are other aspects of being human, but the intelligence aspect is mechanic to us.
How do you make a line between deep machine learning and artificial intelligence?
Yeah. I try to get away, although I use the word a lot, artificial intelligence, how it's called all the time. But we should be more precise and call it's about deep machine learning.
Yeah.
Then we are a bit more down to earth. Then we immediately see, well, it's a technology which is based on large natural language models and other tools which are complex mathematical tools which are fascinating and interesting to critically analyze and epistemologically reflect. But we are a bit away from this ontological question which is attached to artificial intelligence. It's more pragmatic. When we talk about deep machine learning, we realize it's a tool, and but then I remind of Turing as well. Again, in 1950, in his answer to the question, can machine things, he predicts that in the year 2000, computers will be able to behave like a 4-year-old child. Because a 4-year-old child is trained, and this is, should we call it machine learning? But it's certainly trained by language, trained to articulate, trained by learning, to have pattern recognition. But how? By mimicking patterns it sees in its surrounding. By mimicking mother, father, friends, computer games. It's mimicking. And that's how deep machine learning works, because it tries to adapt to patterns in which humans behave, and in way humans speak.
It's creativity in this field as well.
Is this creativity?
Creativity goes into that field as well.
Yeah.
Or not?
Can we then call this creative?
Or where is it? Where is the skill of being creative? Does it go into this? Like, can we just repeat it like other skills we are, embodied into our machine?
Yeah. About this term of creativity, which concerns art a lot, of course, a similar discussion happened like with the term intelligence. How do we define creativity? And we are reminded that for ages, in the Baroque times, or even in all times which experimented with machines, there was always the fascination that machines can be creative. And then humans were irritated for a moment, because naturally it was treated as if only humans can really be creative. Even the first programmer, who was a woman, Ada Lovelace, who developed the algorithmic theory for Charles Babbage, actually who developed the first, as you know, the first mechanical but programmable computer, of which Karl Marx, although he read Babbage, did not really see that's not about matter and energy and...
I'm not a Marxist, I'm
Yeah.
just like a theory of labor.
But that's where Marx failed. And while Marx was sitting in London, in the British Library in London and reading and writing Capital and things like that, and he had heard about Charles Babbage doing this machine, analytical engine and other things, and he missed the point that this is not about production, about fabric production anymore, but this is about algorithm, and this is the new industrial power. That's Karl Marx. But the programmer of Charles Babbage was Ada Lovelace, and she still wrote several times, the machine, the computer, can only do what we tell the machine to do. Until recently, this has been the attitude to computer. It all depends on how clever we program the computer. That the computer can do. But now that algorithms are combined with big data, programmers cannot predict anymore how an algorithm will behave in combination with big data. Now we come to the core of computing theory, Gödel and others, who always said, although the computer looks to us like the most rational machine we ever invented, there is the unpredictability. You cannot write a computer program and know what it can do and what it can't do. It's mathematically unpredictable. This is one of the big unsolved mathematical problems. There's Entscheidungsproblem. You cannot develop a mathematical program which is so perfect that it includes, and it has no contradictions in itself and other things. Now, although we look at computer as the most powerful engine which has ever been invented and the most rational thing, algorithm and things like that, at the core of algorithmic theory is the uncertainty. And this develops in combination with big data.
But isn't it like because the big data can become repetitive, the algorithm can become repetitive and just make a closed circle, and that will be the answer.
Yeah, that exactly, and there is no, and when you write a new program, you cannot know in advance if that will happen or not. So, and that is actually Alan Turing's first paper on computable numbers. He invented the machines, which we, in a way, all use nowadays, to prove what can be done, what cannot be done by this machine. That's something which is very unusual for our thinking. That the computer, in theory, by Turing, was invented to show what computing cannot do. Well, what the computer can do is so much that we think it can almost do everything. But it's interesting to remind that as a mathematical, it's a theory-born machine, the Turing machine, was invented to show what the computer cannot do. And the computer cannot calculate all numbers in between numbers, to put it very roughly. The complex numbers and things like this. And that's why, and first AI in the 1960s was symbolic AI. You can write clever programs which behave like humans, and the first chatbot, Eliza, and you have all this. But this was a dead end. There was always something like true creativity cannot be produced by this. That's why the second effort of machine learning, which we are now experiencing, is the so-called sub-symbolic AI. It's not about logical programming anymore. And it's not reducing human language to logical, grammatical, Chomsky-like structures, but saying, let's start with noise. Human language is mainly about random and noise. And that's the artificial adversarial nets. They don't start by giving an image and then let it produce similar image or recognize similar image. They start with massive noise.
But
and then it's filtered. Yeah.
Isn't the chatbot becoming dumber?
Huh?
Isn't chatbot becoming dumber? There is a study that because of all of the input in the chatbot, its sentences are becoming less complex, and the noise is making it less complex.
If we may break this closed cycle here, just a few things about creativity. This time, because I think that we are operating with the idea that the human is contingent, non-predictable, that the algorithms are in a way predictable, so that they are repetitive, whatever. But already in the 19th century, the statistics, or the sociology, the birth of sociology, this statistical sociology, this famous example of Emile Durkheim, so the father of modern sociology, he predicted the rate of suicide. So the suicide is a social fact. So the human, in a way, is very, very predictable, just like a machine. So I think this is something that is going on when we are talking about creativity, intelligence, and so on. This idea that human intelligence, human culture, human society is contingent, creative, and so on, and that machines are not.
Yeah, and well, statistics in 19th century is so important because it replaced the effort that you can rationally structure the world by the idea that you only can count with probabilities. Statistics says, I cannot know exactly at what year of your life you will die. But from statistical data, I can have a mean value. I can say, you'll probably die rather in this or that age. But it cannot be individually be predicted. And that's similar to machine learning in a way.
But now actually it comes closer, because now we have so much data about people, and this is the basis for machine learning, and things are getting closer
To the end.
in thinking of probabilities.
Well, but that's why I try to differentiate between statistics, we are going to talk, and stochastics. Stochastics is more radical. It's still mathematical, but it's the famous Markov chains, which you all know from writing the alphabet. Markov, he took a Russian poem, Eugen Onegin by Pushkin, I think. No.
Yes,
Yeah, it was.
Pushkin,
Markov in 1913, he took this Eugen Onegin text and he just counted the letters of the alphabet, and he said, what is the probability that after a K follows a U or something? He counted he made it, and then from then he said, how much letters do you need to predict what will come next? And up to the Markov chain of the 0 degree, where you don't need the past, and you just given a string of letters and you can predict what will happen next. Now this is stochastics. It's, you don't have to produce a big archive of statistics. You just have this mathematical probabilities with which you count. And that's applied in machine learning.
And this is also these large language models are actually based upon that probability of the next thing, next token in, I don't know, a string of text or pixels or whatever patterns that is going on.
Yeah. And that's why computer games are so important, because in computer gaming, especially in the action games, the computer has to somehow, he cannot know how a human user will play the computer. But he has to calculate, or the computer has to calculate in real time what are the probabilities, how the user reacts on this game. And that's why the computing industry had to produce those mathematical tools and the processors who do almost parallel processing of data. And those processor kernels are used now in machine learning. But they were first produced for computer games, NVIDIA and other gaming machines. Because they had to cope with this predictability of human behavior.
We are a little bit late, so we have like 5-10 minutes more.
No, we have 20 minutes.
Okay, right. So I want to ask you about your approach, so radical media archaeology. We saw this, let's say, famous vacuum tube. I don't know where is it now.
Oh, actually, where is it? Yeah.
You always
Where's the vacuum tube?
You are emphasizing.
Okay.
You are emphasizing this
That's not that.
hands-on approach to work with materiality of media materiality, and so on. And my question is how to approach artificial intelligence with a hands-on approach, because we are now talking about algorithms, about logic, about black boxes, now about stochastics and so on. So how to approach the state of artificial intelligence now with your approach, hands-on approach?
Yeah. Well, you address now the real challenge to media archaeology. We have in Berlin, for example, a collection of media artifacts like this. This is part of media science in our department. So because we can still, I mentioned it briefly in my talk, say, okay, how the classical computer works, we can in principle show by showing the elementary hardware operations, or we can show how a music synthesizer works by showing the electronics, and even touch it, reduce it to its archaic matter. But since machine learning, the power of machine learning is in the mathematical models, there is no possibility to touch the mathematical model. You cannot put it on a shelf and display and say, students, now this is the core of machine learning. Now, if suddenly the mathematical formula, that's why I like the obvious portrait painting, because they, first of all, to learn to read an algebraic formula, that would be very important, and to put this on display. The famous French philosopher, aesthetician, novelist, Paul Valéry, he once had the challenge how to display mathematics in a museum. How do you show mathematics in a museum? Because it's not an object anymore. It's not an image anymore. So do you paint mathematical formulas on the wall? This is a real challenge. But I insist on one thing. That's why media archaeology cannot reduce to a material artifact, but it's always a techno-mathematical artifact now. And the archaeological in Foucault's sense includes the mathematical discourse as well. This is the one thing. And the other, even the most complicated formula, like we have seen it in the obvious painting, AI-produced painting, mathematics itself cannot act. Either it has to be enacted by human brain, that would Turing say. If we count numbers and say 6 plus 5 equals 11, we are performing a calculating machine in our mind. And so it needs the neural net in our mind to affect this mathematical calculation. And the mathematical formula to produce the portrait of Edmond de Bellamy needs to be enacted by a body, not by a human body, not by a human brain, but maybe by an electronic circuitry. So that there is still something irreducibly material and haptic, even for the most mathematized models. Because mathematics needs to be embodied in order to become operative. Embodiment is a big subject, but then I don't like the word embodiment because we think of human body again. And that's why I insist and say, well, this is maybe a useful model for a human neuron, but it's a completely different embodiment of a neuron. And then it behaves and develops a different intelligence of its own. So, on the one hand, I still insist on the irreducible, artifactual element of AI. At the same time, I say it's not enough to reduce it to that. We have to see it on the mathematical side as well, and that's why I use the word technological verbally. Because when we speak about technological and not just technical, most people would just mingle technical, technological. In everyday language it's almost the same. But technical would be this, but technological means this in combination with mathematics. And only this combination of the material or the matter real with the symbolic order, the mathematical, the ratio, the logos, this produces the beauty and the challenge and the power of technology. The real combined with the symbolic. That's why I insisted on using Lacan's term. The world is not most real when it is matter or energy. But the world is not simply symbolic. It's not just numbers, like Pythagoras in ancient Greek already tried to say, the whole world is mathematics. No, it has been embodied mathematics, and matter has to be mathematized. And this combination of the real with the symbolic is the power of technology and of AI. And the only dimension which is lacking is the so-called imaginary. I don't think that an artificial neural net can develop something like the imaginary, a trauma. That is something which happens, yeah, with embodiment of mathematics, but not with an electric circuitry. But we might redefine the imaginary.
But is imaginary or trauma, as you said, just, let's say, human illusion?
Yeah.
So, you know,
yeah.
we can scientifically understand trauma. So, let's say, an intelligent agent, like a computer machine learning, or whatever, could understand trauma based upon some data that we accumulated about trauma. It's a rational thing, let's say, mathematical. So, why should we think about artificial intelligence and imaginary or this?
The machine learning, probably it does already produce things which emulate what humans call trauma. But then again, in the anthropocentric view, it looks to us as if the machine has a notion of trauma, and then it affects us. But the electronics of the machine has no interest at all whether humans call this trauma or not. The equivalent to trauma in electronics would be a friction or a short circuit or something. Matter itself produces a short circuit. Now, but that's a trauma which comes from the logics of electricity itself and not from a psychic apparatus. But I'm open to
But
a bit, yeah.
some people talked about like geological trauma, like the events that are part of the evolution are traumatic for the matter itself. So this is, I think, a big, another big philosophical subject.
And then philosophy teaches us that we have to be careful about the words we use, how to describe it. I would, together, like Karen Barat, whom I mentioned, easily say, of course, even matter, geological formations can have traumatic experience. The problem is if we use the word trauma, humans are so anthropocentric, they confuse it with what we call trauma in our experience.
Yes.
If we could use the word trauma in a more scientific way, if we could liberate the word trauma and treat it like a scientific term, like a physical or mechanical friction, then of course, geology can have trauma. But I am always careful, or I try to avoid those words which make it easy to use it as a metaphor. Then it becomes human-centered again. And the interesting thing about matter and energy and technology is the non-humanness of it. That's so fascinating. I always remember Aristotle once writing, the human is not the most interesting thing in the universe. What happens in the universe? Humans are just a side effect of it. And so, although Aristotle, I suppose he was human, but we only know texts which have been transmitted over 2,000 years, so who knows? But we assume there was a philosopher, as a human, he was fascinated of the non-human. And humans are, by definition, since they know they are partly machinic, fascinated by machines. That's why they produce actually things which are non-human, although they are challenges to their own subjectivity. But that's the interesting thing about the human, that the human is able to transcend its own humanness. That's why nowadays in discourse the big topic is the non-human or the post-human, which even the non-human still uses the word human, or the post-human doesn't replace the human by a new word, but it says it's post-human. So we are in this, that's part of the definition of the human, that the human likes to play and to challenge its own humanness, even in the most disastrous ways, but that's part of epistemological experimentation, to let the mind free to transcend itself. And that's why Hegel and others struggled with expressions like objectivation of the mind. Is it then still mind or not? And what are the limits of the human? But again, I would say, let's rather let artificial intelligence remind us of the artificiality of within the human itself. Then it will be a more interesting relation and experimental situation between those two entities.
Okay, any other questions?
I have one last question. So, what are your speculations when we will let the artificial intelligence free just to play, to create from its own field?
Yeah.
How will this affect, I would say, society, human beings? What we are going to be free of? Because there's always like hand-in-hand connection. So just your speculations.
Mm-hmm. Well, will it affect, to what degree will it affect the human society if we let the machine learning and artificial intelligence develop its own creativity? It will have one effect on human society, that we will concentrate on different things then. Well, I don't know what those things will be. Painting did not stop when photography was invented. but it suddenly started to experiment with pointillism and things like that. Something which photography does not in that way, or cubism, or something. Then suddenly realism was performed much better by photography, producing a realistic portrait of the human. For that, photography was much better, but that was not the end of painting. But then painting could develop experiments which photography in itself does not do. So it's a liberation of both sides.
Thank you for your lecture. I was thinking a lot about the aspect of materiality that you mentioned several times. So minerals and water and the elements. And as I understood you, so now with the artificial intelligence, the level of the autonomy of the elements, of the minerals, is maybe a bit higher. So then I started to think about the intelligence of the minerals of themselves. So maybe now we are giving more space to the elements itself to develop their imaginary, or whatever we call it, potentiality. I mean, the planet itself is the most imaginary matter that we can think of or observe. So maybe with this artificial intelligence, we are giving space to the elements themselves to have a dialogue, or so it is not human and computers, but also the level of the materials that are used by themselves.
Yeah, and so far, since the mineral so far could not maybe express its own intelligence in a way which we would call intelligent, but if the minerals are informatized, then they are given the chance to articulate their own intelligence. But as if it's the sort of what in philosophy is called the anthropic version of the universe. Why are there humans in the universe at all? Because the universe, in order to become self-conscious, needed humans. So and we are maybe in a similar state with the minerals. The minerals has sort of latent intelligence, but in order to let this intelligence be articulated, it needs to be developed by knowledge, by informatization and things like that. But then that's, yeah, so we still play a role, but it's not that we impose human knowledge on matter anymore, but matter needs the humans in order to articulate its own technologies. And I think a lot of up-to-date so-called speculative philosophy or inactive materialism, or there are several terms which I use, are all about that. But that's why I'm not that much pessimistic about the so-called Anthropocene. To most people it's a big disaster that now for the first time human culture acts on the physical earth, that it changes the geological and ecological and other aspects of the earth itself. But in a more positive version, the earth can suddenly articulate its knowledge. It's a problematic argument, but I try to see it a bit more optimistic. Because the human fascination, I think, will not be able to resist the temptation of acting on matter, even if that changes the climate. But even nowadays, the climate discourse that we can correct the disaster by 1.0 or whatever, 1.5 degree and things like that, this is already a technological attitude to climate. We can correct it.
First of all, we need to understand the compute
Yes.
the climate too.
Exactly. All the climate data, they
Yes,
are
yes.
computed. So the message,
Computational thing.
the message of the climate crisis is already a media message.
Yes.
We have already accepted the role of the computation.
Yes.
So this would be a more sort of optimistic interpretation of the Anthropocene.
I think this is a very appropriate,
Optimistic.
appropriate way to start.
Yeah. Okay.
And then just-
Thank you for this.
So
Yeah.
thank you
Thank
again,
you.
and
Thank you.
thank you all.